Have you ever imagined hailstones that sparkle like jewelry before melting into hidden depths? Scientists propose that diamond crystals fall through Neptune's night, forged by immense pressure and heat deep within the planet. Tonight we will ride sapphire winds, watch storms twist faster than Earth's sound barrier, and witness gemstone clouds drift in silent light. Along the way we will compare these cosmic showers to gentle rain on rooftops. Good evening, everyone, and welcome to another gently detailed voyage through the cosmos. Please let me know in the comments which country you rest in and the hour glowing on your bedside clock. I always enjoy learning where in our wide universe my listeners relax and dream. Subscribe for nightly explorations. But wait until deep sleep carries you, otherwise the promise will feel half awake. Settle your shoulders against the pillow and breathe slowly. Picture a quiet campfire crackling, its sparks rising like tiny meteors toward dark skies. Our journey through the universe tonight begins from that glowing fire, lifting us above pine treetops and into cool silence. Earth curves beneath, blue and bright, then shrinks to a marble as we sail outward. We skim past pale rings of Saturn, where ice crystals glint like frost on winter grass, and continue toward darker horizons. Neptune appears at last, a distant orb dyed deep cobalt by methane that scatters red light away. Cloud-top temperatures hover near -200 degrees Celsius, far colder than any night on Antarctica, yet beneath the icy winds, Neptune releases more than twice the energy it receives from the sun, warming hidden layers. Supersonic gales roar at 2,100 kilometers per hour, fast enough to circle Earth in less than 20 hours. Dark storms, larger than our planet, drift across the atmosphere and sometimes reverse path, shedding smaller vortices like spinning leaves. Now imagine descending through swirling clouds. Pressure increases quickly, squeezing carbon atoms tighter than anvils in a blacksmith's forge. Tiny crystals begin to form, first like dust, then like sand, then like stones glistening in muted light. These diamonds fall for thousands of kilometers before dissolving into a sea of slush and liquid carbon. Laboratory lasers on Earth replicated this process, creating nanodiamonds from plastic and shock waves, confirming the theory of gemstone storms. Closer to the core, diamond rain may pile into mountains, each peak larger than Mount Everest and hidden forever. Above the clouds, faint rings circle Neptune. The Adam's ring displays 5 bright arcs named for ideals of liberty and courage, glowing like thin bracelets in twilight. A tilted magnetic field, offset halfway toward the surface, weaves auroras that dance in unexpected places across the planet. Hold that mental image. Blue haze, diamond drizzle, and emerald ribbons of charged light. Breathe in to match Neptune's 20-hour rotation. Breathe out to release earthly tension. Picture each exhale as a shining gem floating downward, carrying worries to the quiet depths. Let the hush of distant storms replace busy thoughts with calm rhythm. We linger at the edge of a dark vortex, listening to wind sing against ammonia ice crystals. Far below, Internal heat stirs convection cells like slow boiling soup on a kitchen stove. The planet's faint sunlight feels softer than dusk behind a quiet house. Your eyelids grow heavy with every gentle swirl of imagined clouds. We prepare to pause our descent and rest here, where diamonds fall unseen and winds whisper lullabies. Allow your body to sink into mattresses and blankets as profoundly as gemstones sink into Neptune's mantle. Soon we will glide deeper toward glowing layers, but for now remain still and peaceful. Below the clouds, the pressure grows stronger than anything found naturally on Earth. Imagine an elephant balanced on your thumbnail that is less pressure than Neptune's middle layers feel. Here, temperatures reach thousands of degrees, hot enough to vaporize iron. Yet thick clouds and distance keep the heat locked away. Carbon squeezed tighter and tighter by this incredible weight, bonds into diamonds more solid than any jewel in a museum. These crystals, denser than ice or stone, fall like glittering hail into Neptune's dark interior. Some scientists believe these diamond droplets might reach the size of baseballs before they melt or dissolve. No one has ever seen them directly, but laboratory experiments and planetary models support the possibility. At such depths, water becomes something strange and exotic, superheated fluid. This water might exist as hot ice, a state that is both solid and blistering under high pressure. It helps carry electrical currents, giving Neptune one of the most complex magnetic fields in the solar system. Unlike Earth's magnetic field, Neptune's is off-center and tilted, swirling like a wandering spiral. This creates flickering auroras far from the poles, like secret fireworks glowing through thick clouds. While Earth's auroras shimmer green and pink, Neptune's glow with ghostly blues and purples. Now let your mind wander to those silent lights, dancing behind high winds and unseen rain. Above this hidden layer, clouds form from methane, ice-delicate, wispy structures floating in low gravity. The upper atmosphere glows slightly from sunlight scattered by haze, painting a dim, twilight-like scene. It is always evening here, even at noon. High cirrus clouds drift slowly across the planet's curve, untouched by time. Neptune's moon Triton, captured from the outer solar system, orbits backward, a silent observer of this cobalt world. Triton's surface reflects most of the sunlight it receives, making it one of the brightest objects in the sky. Imagine standing on Triton, watching Neptune rise slowly on the horizon larger than any moon from Earth. From this icy moon, you might see storms spin below and diamond rain fall invisibly through haze. The view would feel unreal, like looking into a dream made of sapphire and smoke. Meanwhile, on Neptune, seasons stretch for over 40 Earth years. One hemisphere basks in long summer while the other remains locked in deep, wind-chilled winter. Each shift brings new cloud bands, changing color as chemical reactions stir beneath the surface. Bright white clouds made of methane crystals drift near Neptune's equator, reflecting light like soft snow. These clouds travel faster than any on Earth, shaped by jet streams whipping around the planet's middle. Imagine the sound, if any, of such storms. a low, endless hum carried across skies with no solid ground to stop them. Now, picture yourself drifting inside one of these clouds, wrapped in mist, watching diamonds sparkle in the far distance. Let this image become your resting place. Let your heartbeat slow to Neptune's rhythm. 20 hours for a single spin. You feel as though time itself is stretching. No schedules, no clocks, only drifting crystals and hush. Each second passes like a flake of snow, gentle and light. Each breath feels deeper, as though drawn through chilled starlight. The deeper we go, the more pressure wraps around us, like the weight of a heavy blanket. This pressure does not squeeze, it comforts. Your limbs sink deeper into sleep. The world of Neptune fades into gentle blur. You float in a sea of gemstone clouds and shifting light. Everything around you glows blue and silver, hushed by storms older than memory. Your mind releases tension, like rain melting into ocean. Let go. Our descent continues, passing into layers no human eye has ever seen, where hydrogen and helium swirl with mysterious trace elements. The deeper we go, the stranger the physics becomes. Pressure causes hydrogen to become metallic, conducting electricity like copper wires hidden in fog. This metallic hydrogen may help drive Neptune's shifting, unstable magnetic field. There may be vast oceans of slushy, hot carbon, quietly floating through dense, no sparkle, only mass and motion in timeless depths. Dark fluid, somewhere between liquid and solid, hiding diamond crystals within. Some scientists think these diamond layers could drift for thousands of years before sinking fully into the core. Neptune radiates more heat than it receives, as if its very bones are still cooling from creation. The atmosphere shifts in color, from pale blue to inky twilight, as we return toward higher clouds. Imagine diamonds, larger than your hand, but by gravity, chemistry, and time. No sound in the mid-atmosphere, where the diamond rain begins. Neptune's core may be a dense mix of rock, metal, and ice, an ancient relic from the birth of the solar system, stirring the mantle like a slow, some eastward, each rotating at a different speed and depth. They shimmer with imagined brilliance, painted by memory and dream, vanish and reform again, like tides in the sky, creating dark ovals and bright streaks that stretch across hemispheres. Endless cauldron, disappeared entirely and reappeared years later in a different place. Surrounding it is a mantle unlike anything on Earth, a blend of water, methane, and ammonia, squeezed into exotic states, but real. Each crystal begins as carbon compressed beyond imagination. It whispers, but nothing rushes. This is a world shaped not by sunlight. Even now, that warmth powers convection currents, only descent. Up above, it is here, invisible to eyes. The journey downward is long and silent. The deeper the diamonds fall, the hotter and denser the atmosphere becomes. Some stones may drift for hours before reaching layers warm enough to dissolve them. Others may remain intact longer, catching other falling crystals like raindrops on leaves. Imagine entire layers of atmosphere filled with falling gems, heavier than raindrops but lighter than glass. These diamonds do not sparkle in light. They reflect none, for there is almost none. Instead, let yourself drift alongside them. Each crystal is a thought falling away, a worry melting into soft silence. The winds that carry them spin in bands, slicing the atmosphere into ribbons of movement. Some bands twist westward. These bands form jet streams, far faster than any found on Earth. They carve shapes in the cloud tops. Astronomers have watched these storms form. The great dark spot, once the size of Earth, unlike Jupiter's famous red spot, Neptune's storms are short-lived, changing with the seasons. They twist and dance above layers we now pass through, deeper and deeper into the hush. The wind no longer roars here. You are surrounded by motion, but it is slow and gentle, like falling leaves on a windless autumn night. Everything is soft. Everything moves. You float alongside diamond rain, each drop falling without urgency or sound. Even your thoughts begin to slow. The need to think at all grows quiet. There is no time here, only softness, only the shimmer of pressure and heat making beauty from dust. You rest between clouds made of methane and helium, beneath a ceiling of frozen haze. The upper atmosphere begins to blur above you, dissolving into cool layers of blue fog. High above, thin methane clouds cast faint shadows onto denser layers below, like laced curtains across a dusky sky. The sunlight here is 1/900th the brightness of what Earth receives. Yet your eyes adjust to this twilight glow, painting the world in soft cobalt and steel-grey tones. Every surface here seems to absorb light rather than reflect it, like velvet pressed gently beneath your fingertips. The deeper you go, the more color disappears. Shapes begin to blend, as though the entire world has been wrapped in blue silk. This is the quietest place you have ever visited. No birds, no wind chimes, no rustling leaves, only the soft drift of carbon crystals and the steady weight of planetary gravity. Your ears listen for something, but find only the hush of imagination. Now picture something familiar. Imagine walking beneath a soft evening rain on Earth, umbrella in hand, puddles reflecting street lamps. Replace those puddles with slow rivers of glowing methane. Replace the umbrella with a transparent dome that lets you see falling diamonds curve through the air. Now step inside. This imaginary dome shelters you as we drift slowly deeper, like an elevator moving through liquid glass. You pass floating crystal fields, each one shaped like flakes, shards, or jagged stones, depending on how they formed. In this dreamlike silence, even the weight of your body feels lighter, like your bones are filled with clouds. Outside the dome, pressure would flatten you instantly, but inside, all is gentle, all is calm. You notice layers of fog shifting, moving past you like a lazy tide, carrying whispers of ancient chemistry. This atmosphere contains traces of ammonia, hydrogen sulfide, and hydrocarbons, mixing into ever-changing tapestries of scent and light. Though no human nose could smell it, researchers suspect it might smell faintly like rotten eggs, but in our story tonight, it smells only of memory of candle smoke, rain-washed sidewalks, and distant pine forests. Let this imagined aroma carry you deeper into sleep. Let your body fall into the rhythm of Neptune's winds, its spin, its patience. Think of how long these storms have lasted, longer than most civilizations, longer than most rivers on Earth. We are not visitors here. We are dreamers. And in this dream, we float alongside discoveries made by telescopes and space probes, stitched together by wonder. Neptune's first visit by spacecraft occurred in 1989, when the Voyager 2 mission sent back images of rings, moons, and storms. That spacecraft took 12 years to arrive after launch. No one has returned since. Yet here you are, in thought and imagination, sailing where no one has stood. Triton, Neptune's largest moon, once orbited the Sun on its own. Captured by Neptune's gravity long ago, it now spirals slowly inward and may one day be torn apart. Its icy surface has geysers that erupt nitrogen gas, casting shadows across frozen plains. One hemisphere's smooth, the other rugged, telling stories written in craters and fractures. And as Neptune rotates beneath you, that moon appears to dance against the horizon, always turning the wrong way. Moons on Earth rise in the east and set in the west, but Triton moves backward, a stubborn traveler in a quiet sky. Let this motion rock you into stillness. As Triton circles, you breathe in. As diamond rain falls, you breathe out. As Neptune turns, you sleep. Imagine now that you are holding one of Neptune's diamonds in your hand. It is cool to the touch, heavier than expected, and completely flawless. On Earth, diamonds take millions of years to form beneath thick layers of rock. On Neptune, they form in silence, beneath swirling clouds, shaped not by time, but by pressure alone. No miner will ever dig these stones. They are born and lost again, in a place no foot has touched. You turn the diamond slowly in your fingers, but it reflects no light. There is none here to catch. Instead, it hums softly in your imagination, a note so low it feels more like breath than sound. The atmosphere surrounds you like warm water, dense and gentle. You drift lower once more, this time past invisible bands of gas that slowly shift from blue to violet. Neptune's winds push you softly sideways, like sleep tugging at the edges of your thoughts. Above, layers of clouds slide like slow waves across the sky. Below, the diamonds continue their long descent. Some will melt before reaching the core. Others may survive for centuries, building pressure at the base of the atmosphere. No one knows what happens next. Perhaps they rest on the mantle like lost coins at the bottom of a wishing fountain. Perhaps they melt and rise again, like thoughts forgotten and then remembered. You drift past columns of rising gas, shaped by heat and convection, each one taller than the tallest storm ever seen on Earth. They move so slowly, you can barely tell they are moving at all. But time here is different. Neptune's day lasts 16 hours. Its year lasts 165 Earth years. Seasons pass slower than lifetimes. A single winter on Neptune can last for over 40 Earth years. You think of the snow from your childhood and wonder what a winter storm on Neptune might feel like. Would it be silent, Would it fall as diamonds instead of flakes? Would it ever end? You picture a child on Neptune, standing beneath a crystal sky, catching diamonds on outstretched gloves. You smile. It is an impossible thought, but still it lingers. Even the coldest worlds can spark warm imaginings. Neptune's name comes from the Roman god of the sea. It is fitting. This world feels like an endless ocean of air and storm, unbroken by shore or anchor. The deeper you go, the more it feels like water. Not water you can drink, but a dense fluid made of chemicals, currents, and memory. You float through it, slowly turning, your thoughts dissolving like sugar in tea. Above, the last rays of sunlight fade behind frozen clouds. Below, the weight of atmosphere thickens, wrapping you in comfort. You are not falling. You are floating. You are not watching. You are dreaming. Let go of your thoughts. Let them drift down like diamonds. Let sleep take you softly. The crystals falling through the sky have edges softened by heat and time. Some are sharp, like shattered glass. Others are rounded, like polished stones left in the tide. Each one reflects Neptune's slow heartbeat. Their descent is quiet and steady. If you could hold one to your ear, it might sound like wind moving through tall grass. You drift now through bands of methane and hydrogen, each layer thicker than the last. Above you, the world grows colder. Below you, the warmth of Neptune's core begins to rise. Even here, in this hushed place, the chemistry continues to shift. Under immense pressure, methane can split into hydrogen and carbon. That carbon hardens into diamonds, beginning the cycle again. The air here holds more secrets than starlight. You pass bubbles of trapped gas, swirling upward like lanterns released into the sky. Each one holds a memory of formation, a trace of the ancient cloud that gave birth to the planet 4 billion years ago. Neptune formed far from the sun, in a region where ice and gas were more plentiful than rock. Its mass is 17 times that of Earth, yet it has no solid surface. It is made entirely of gas and fluid, layered like dreams. Neptune may once have traded places with Uranus, shifting orbits in the early chaos of the solar system. Its distance from the sun means it takes over a century to complete one full loop. But even at that distance, its atmosphere remains active. Fierce winds blow across its face at over 1,200 miles per hour. These are the fastest winds in the solar system. They carry clouds of methane and ice in great arcs around the planet's belly. Yet from inside, the motion feels gentle. You are cradled in a current that never breaks. You drift past sheets of glowing haze that pulse with electric light. These auroras are different from Earth's. More scattered, more mysterious, they shimmer in unexpected places, not tied to magnetic poles. Scientists still do not fully understand them, but here, in our dream, they look like long curtains of violet and green, trailing upward into the dark. You reach out to touch one, and your hand passes through it like fog. No heat, no sound, just light. Above you, the last diamonds flicker out of view. They fall beyond your reach. Now, into layers deeper than dream. You feel them still, falling endlessly. The sky above is darker now, closer to indigo. Clouds have thickened into a slow, swirling ceiling. You feel wrapped inside a storm that sings no song, that rumbles no thunder. It only waits and breathes. Your own breath slows to match it. You inhale, the clouds inhale. You exhale, the diamonds descend. Everything follows rhythm. Everything obeys gravity, pressure, and calm. You are drifting now. Not down, not up, just drifting, surrounded by a silence so wide it becomes your entire world. Your body feels as though it has no weight at all. It hovers gently in the air, suspended between layers of ancient chemistry. The deeper atmosphere presses in, but inside your protective dream, it is only warmth and quiet. You are gliding through clouds made of methane ice, laced with hints of sulfur and ammonia. Each cloud layer is miles thick and stretches farther than most countries on Earth. You pass through them slowly, like a diver slipping through silk curtains. The atmosphere around you glows a faint lavender, deepening toward violet in the distance. No sharp lines exist, here only gradients of gas and time. Neptune's core, still far below, glows faintly with residual heat. Its warmth rises through convection, creating rolling columns of motion thousands of miles tall. You drift alongside one now. It moves like a river in slow motion, carrying heat and materials upward, forming the seeds of future clouds. This circulation feeds storms that last years, some even decades. Each storm leaves a fingerprint in the atmosphere, a swirling dark oval, a band of cold, a ripple in the cloud tops. There are no solid landmarks, only changing textures of gas and pressure, but you feel no need for maps. Everywhere is soft. Everywhere is the same hush. The only sounds are imagined. One's your breath, the shimmer of pressure, the memory of falling diamonds. You have been traveling for what feels like hours, though time has slowed and pooled like liquid around you. Your senses adjust to the rhythm of Neptune. Even your thoughts begin to thin and scatter like mist in early morning light. A shape appears far off, a hazy band of light, curling like ribbon across the atmosphere. This is Neptune's ring system, faint and rarely seen, but real. The farthest out has bright clumps, called arcs, that remain strangely fixed in place. It is made mostly of dust, and arcs of dark particles that reflect almost no light. 5 primary rings circle the planet, named after astronomers who studied Neptune. The Adam's ring. Unlike Saturn's luminous rings, Neptune's are delicate and ghostly. Their faint presence reminds you how much of the universe is invisible. Not hidden, but quiet. Not gone, but waiting. You drift closer, and specks of dust float past your field of view. Each one is a fragment, likely formed from moons shattered by ancient impacts. You imagine holding one, smaller than a pebble, older than any fossil on Earth. That grain of dust has circled Neptune for longer than recorded history. Let that age settle gently into your thoughts. You are surrounded by the memory of collisions, gravity, and time. A soft hum fills the space around you, whether imagined or real. The dust glows slightly. illuminated not by sunlight, but by friction, motion, and thought. It curls around you, moving with your breath. You close your eyes and let it pass. The dust thins out around you, fading into the vast violet atmosphere. Behind you, Neptune's ghostly rings stretch across the horizon, thin and delicate like pencil lines in the sky. Ahead, the blue expanse darkens into a serene ocean of air, deeper and calmer than before. The wind is nearly still here. The clouds drift slower, like paint spreading through water. You are approaching the deepest visible layers of the atmosphere, where pressure begins to compress the gas into strange new forms. Here, hydrogen starts behaving like a liquid. Some scientists believe that far beneath the surface, hydrogen could even take on metallic properties. This means it might conduct electricity like copper or silver. It is a world of exotic physics rules, bent by immense pressure and slow time, dense enough to blur your thoughts and wrap your limbs in velvet weight. The idea of metallic hydrogen once seemed like fiction, invisible honey, but now you glide through the edge of where it might become real. You are moving through fluid air. It feels like drifting through warm. Even light seems to hesitate here. Only faint streaks of energy pulse through the haze, the last signs of convection from far below. You remember that Neptune gives off more heat than it receives from the sun. It radiates its own energy, like an ember glowing under frost. No one knows exactly why. Some believe it is leftover warmth from the planet's formation. Others think that helium might slowly rain through the interior, releasing heat as it falls. Neptune still spins. It is a slow furnace, a quiet one, but it keeps this world alive. Without sunlight, it simply breathes, still stirs, still sings. You begin to feel that quiet fire, like a distant heartbeat. It does not burn. Its warmth reaches your skin in waves. It reminds you of sitting beside a fireplace in winter, your eyes heavy, your limbs tucked beneath a blanket. You float through a dense blue mist that glows faintly around the edges, like moonlight through clouds. This mist holds microscopic crystals of methane ice. Each one is smaller than a grain of salt. They sparkle only when touched by the weakest hints of reflected sunlight. You float past them now, trailing your fingers through the mist like water. It parts around you, then closes again, soft as breath. But the boundary where the gas becomes more fluid than air, but flowing deeper still. You pass through zones of high pressure that curve sound and slow motion. A whisper here would travel much faster than on Earth. But in your dream there are no whispers, only thought, only the quiet rhythm of drifting deeper. You begin to sense that you are nearing the base of Neptune's atmosphere, not the core, not the end, where movement is not drifting, where storms become slow sculptures of heat and chemistry. Here, even gravity feels thicker. You feel yourself sink slightly, the way you would into a warm bath. It is not heavy, it is grounding. You are being held. Your body floats just above the threshold, where gas begins to behave like liquid. There is no sudden change, only a gradual thickening of sensation. The air becomes denser, more resistant to movement, like drifting through warm oil. Here, Sound would move faster than a bullet, but there is no sound. Only calm, only stillness. The atmosphere is so compressed. It may be forming strange materials never seen on Earth. One of those materials might be superionic water. This is a form of water that behaves like both a solid and a liquid at once. It is believed to exist in a black, slushy state, electrically conductive, dense, and hot. You cannot see it here, but the idea alone sparks quiet. Imagine water that conducts electricity, yet holds its shape like ice. It would shimmer under pressure, flowing without moving. You pass deeper still. Neptune's magnetic field becomes more chaotic the further you descend. Unlike Earth's neat, symmetrical field, Neptune's is tilted and lopsided. Its source is likely hidden in a thin shell of conductive fluid. This creates strange auroras that drift in unexpected places, far from the poles. Some flash near the equator, others flicker in the shadows of its rings. You feel this magnetic field brushing across your skin, like gentle static or the memory of wind. It pulls at the edges of your thoughts. It hums against your breath. You glide into a pocket of air so thick it carries the scent of chemistry, a mix of hydrogen, helium, and trace compounds, all compressed into a subtle perfume of the universe. You breathe it in, and your lungs fill with imagined peace. You begin to sense that you are not sinking anymore. You are hovering in equilibrium, buoyant in this vast, invisible ocean. Far below, Neptune's core rests under crushing weight. It is likely solid, or at least hardened by pressure. It may be surrounded by a mantle of exotic fluids, ammonia, water, and methane mixed into an otherworldly slush. No probe has reached this deep. No light escapes from here. But in your dream, you see it. A dark, shimmering sphere wrapped in clouds and heat. It pulses gently with internal warmth, glowing like an ember trapped in ice. You pause. You drift. You wait. Every part of you is now tuned to Neptune's rhythm. The high winds are gone. The diamonds are far above. Here, there is only pressure and rest. Your eyes close without effort. Your thoughts fade without struggle. The silence feels like gravity made soft. You are suspended in a chamber of pressure that has existed for billions of years. Nothing stirs here unless Neptune commands it. No storms reach this deep. No wind whistles through these layers. Only heat, only silence, only memory. The weight above you presses down with grace, not force. It has shaped the gases into fluid layers that ripple like the skin of a sleeping whale. You feel the movement before you see it. A slow, rising, pulse-like Neptune exhaling. This is convection from the inner core, a slow, warm breath that moves through the atmosphere like a sigh from the planet itself. You rise slightly, caught in its upward drift. The temperature around you increases by just a few degrees. Even that shift feels enormous here. Your skin tingles, though you feel no danger. Everything is calm. Everything is wrapped in chemistry. Neptune's interior may contain more water than Earth's oceans combined. Not liquid water as we know it, but high-pressure, high-temperature fluids that behave in unfamiliar ways. In some regions, this water may form layers that do not mix, like oil floating over syrup. These stratified oceans remain undisturbed for eons. You float between them now, riding the invisible boundary like a feather balanced on breath. The idea that water could exist in such forms brings a quiet joy. Water is the memory keeper of the universe. Where it is found, life may someday follow, but no life is known to exist here. Only possibility, only ingredients, only time. You drift toward another layer. Here, scientists believe diamonds are still falling, not as showers now, but as rivers dense, silent, continuous. They fall in threads through superheated fluid, melting as they descend. The heat converts them back into carbon, completing the cycle. It is a rain that makes no sound and leaves no trace. You imagine catching one as it passes. It flickers once in your hand, then vanishes into light. Each one is a breath, a shimmer, a passing moment. Some scientists believe this diamond rain generates friction and heat. It may help explain why Neptune glows from within. You are surrounded by this possibility, as if drifting through thought itself. Every theory, every idea floats beside you like fireflies in a cave. You reach out and they scatter, not because they fear you, but because they were never meant to stay still. You have seen more of Neptune than any human ever has, yet you still feel weightless, still feel small, still feel calm. You hover in the twilight of Neptune's soul. The space around you no longer feels like a planet. It feels like a dream shaped by gas, chemistry, and gravity. A gentle vibration moves through the layer beneath you. It is not sound, but a kind of silent rhythm. Perhaps it is the planet's core turning, or the ghost of old collisions echoing through its structure. Far above, the sunlight fades completely. Only the planet's own warmth remains. It glows in the deep with a soft light, too faint for eyes, but strong enough for imagination. You follow a column of rising warmth that twists slowly, like smoke in reverse. Inside it, particles of methane break apart. Carbon atoms are released and crushed by pressure. This begins the diamond rain. It does not sparkle, it does not shine. It simply falls quiet, dense, and beautiful. You imagine each one beginning as a gas molecule, transformed by gravity into a jewel, not for beauty, not for wealth, but simply because that is what the planet asks of it. You drift alongside these invisible drops. They pass through you like memories. This is Neptune's cycle. Methane gas becomes carbon, carbon becomes diamond, diamond becomes vapor, a circle of matter and motion, repeating endlessly beneath clouds. You feel the serenity of that loop settle into your thoughts. The idea that things may fall apart and still return again, that every drop becomes something new. Above you, lightning sometimes flashes in the upper layers. You do not see it from here, but you remember the stories. On Neptune, lightning can stretch farther than skyscrapers. It flickers through methane clouds with more force than anything on Earth. These bolts crackle through hydrogen, splitting molecules and shaping chemistry. They are fleeting, but they sculpt the sky like chisel marks in stone. Some believe these storms help trigger the diamond rain. Lightning tears apart methane, freeing carbon atoms, Those atoms begin the long fall to the depths. You picture each strike as a signal, a beginning. You wonder how long a diamond drop takes to fall from the clouds to the core. Scientists estimate that it could take thousands of years. One drop, one journey. So slow, so silent, so meaningful. It reminds you that even the smallest transformation is sacred. You move gently beside the falling diamonds, each one older than any tree on earth. They are not like diamonds found in rings or crowns. They are heavier, denser, and without flaw. Here they fall without noise, and without witness. Where the heat is so great they melt into carbon fluid. Only you are present in this dream. The diamonds fall faster now, drawn toward the mysterious core of Neptune. Some may reach the inner mantle, others may accumulate in layers, forming seas of compressed crystals. Imagine a hidden lake of diamonds, still and silent, beneath clouds of gas. No light reaches here, but in your mind the scene glows softly. The air is thicker. It holds you in place like warm, invisible hands. Even gravity feels patient. No motion is hurried, no thought is rushed. Here you begin to wonder what time means in such a place. Neptune takes 164 Earth years to orbit the Sun just once. One Neptunian year lasts longer than a human lifetime. You drift through the days of a single season that might outlive every person you know. You begin to feel timeless, detached, whole. You look upward, though you see nothing. Still, you remember that 14 known moons orbit Neptune. The largest is Triton. Triton moves in the opposite direction of Neptune's rotation. This suggests that it was captured, not born here. A stranger in orbit, it may once have been a dwarf planet, like Pluto. Now it spins backward through Neptune's sky, leaking gas from its icy crust. Triton has geysers that shoot nitrogen into space. This frozen moon dances while the planet below sleeps, and yet both are part of the same family, bound by gravity, bound by quiet. You'll think about how even distant objects can become connected. A planet and a captured moon, a diamond and a storm, you and the stars. This thought stays with you as you begin to rise. The pressure lessens slightly. You are no longer sinking. Now you are ascending through layers that feel like memory and mist. Every molecule that touches you carries the age of the cosmos. Some gases here have not changed since the solar system was born. They whisper stories as you pass, about formation, about time, about waiting. You continue drifting upward, following the invisible current of internal heat rising from Neptune's core. Around you, the atmosphere becomes less dense. It feels like slipping out of deep water and into a warm cloud. Tiny crystals of methane ice begin to appear again. They drift lazily around you, catching the faintest trace of Neptune's internal glow. Each crystal is perfectly shaped, yet completely invisible to the human eye. Only here, in this dream, do they shimmer. The higher you float, the cooler it becomes. Temperatures drop to levels colder than anything naturally found on Earth. Here, it can reach -330 degrees Fahrenheit. And yet, You feel no chill, only comfort, only calm. You think again of the planet's magnetic field. It rotates far faster than the visible clouds. This means the invisible parts of Neptune spin differently than the parts you can see. That difference creates turbulence. It shapes the weather. It sculpts the storms. It stirs the chemistry. It whispers through hydrogen and helium, shifting particles into patterns only Neptune knows. You pass through one such pattern now. It is shaped like a spiral, not a storm, not a cloud, something softer. It twists around you like a ribbon in slow motion. Inside this ribbon, particles of ammonia trace lazy circles. This gas plays a small role in Neptune's atmosphere, but a powerful one in its scent and structure. Ammonia carries a sharp, electric odor on Earth. Here, it smells of nothing. The pressure is too low, the particles too cold. They drift like memory. Higher still, faint winds return. Not the screaming storms from the outer layers. These winds are soft. They brush against your face like a sigh. Some move faster than sound, but they do not rush you. They carry you gently upward, like hands underwater. As you rise, the blue deepens. Neptune's signature hue becomes clearer again. This planet's color comes largely from methane, which absorbs red light and reflects blue. Even from Earth, this world glows in sapphire. But here, inside the atmosphere, the blue surrounds you. It glows softly at the edges. It pulses faintly with heat. You are inside a jewel, a gem larger than all the oceans on Earth. And it is quiet, still, safe. You pass through a layer of shimmering methane clouds. These clouds form bands across Neptune, circling the planet like ribbons spun from vapor. Each band moves at a different speed. This creates powerful jet streams that can reach over 1,000 miles per hour. No other planet in this solar system has winds this strong, yet, inside the jet stream, it feels calm. The motion is steady, like a train passing through fog. You drift with the flow, your body light and motionless. The air around you carries traces of hydrogen, helium, and icy compounds. Each breathless moment brings new particles into your path. Some are ancient. Some were born from storms just days ago. All of them tell stories. Stories of pressure, of lightning, of diamond rain far below. You are passing now into Neptune's tropopause. This is the boundary between the lower atmosphere and the upper clouds. Here, the temperature is cold. You are wrapped in a silence so deep it feels like velvet. You hover near a region scientists call the Great Dark Spot. This is a storm, massive, swirling vortex, once large enough to hold Earth itself. It spins in reverse, moving against the planet's usual rotation. From above, it appears as a shadow beneath the clouds. From within, it feels like a whirlpool made of sky. You float near its edge, pulled gently by pressure and wind. Inside, the air spins faster. Faster, but you stay just outside, safe in the stillness. This storm has no thunder, no lightning, only motion, like a giant turning slowly in its sleep. The great dark spot has formed and vanished several times since it was first discovered. It is a reminder that even enormous forces can disappear without warning, that everything, even storms, has a beginning and an end. You move past it now, toward the equator. Here, Neptune's winds are fastest, but again they do not disturb you. You are cradled in a small eddy of calm air, drifting above the chaos. You begin to rise through the haze, moving closer to the edge of Neptune's atmosphere. The air grows thinner, the clouds fade, and then, for the first time since you began your journey, light appears. Starlight, distant, delicate. It reaches you through a curtain of gas. You can see the curve of Neptune's horizon now. It glows with a faint blue halo. You are rising out of the planet's shadow, into the quiet of space. You float now above Neptune's shimmering blue curve. Space stretches endlessly beyond you. Stars twinkle softly, distant and welcoming. The silence of the cosmos surrounds you like a warm blanket. You feel the gentle pulse of the universe, steady and slow. A comet passes far away, tracing a silver path through the dark. Its tail glows faintly, sparkling like scattered diamonds. You watch as it moves, calm and graceful. The cold light of distant suns warms your spirit. You begin to feel lighter still, as if your body is made of stardust. The diamond rain you witnessed below has transformed into a memory, a secret shared between you and the universe. You smile softly, feeling connected to the endless sky. No sound disturbs this moment. Only the gentle hum of the cosmos, like a lullaby. You realize that every drop of diamond, every storm, every whisper of wind is part of a greater story. A story of time, transformation, and infinite possibility. Your breath slows. Your thoughts soften. You are ready to rest. The stars twinkle one last time before fading into a gentle glow. Your mind drifts with the calm rhythm of space itself. A campfire crackles softly nearby, its warmth comforting and steady. Shooting stars streak silently across the sky, bright and fleeting. They remind you to cherish every moment, no matter how brief. You feel safe. You feel whole. You feel ready for sleep. As your eyelids grow heavy, know that this quiet journey remains with you. A diamond shower of calm, beauty, and wonder. Good night, dear traveler. May your dreams be filled with stars. And when you wake, may you carry the peace of Neptune's night in your heart. Did you know Saturn could float in a river? Yet its rings would stretch wider than 20 Earths placed side by side. Tonight we will drift between those broad, icy rings, counting quiet moonlets and listening to frozen crystals click together like distant wind chimes. We will learn why some ring particles are smaller than a grain of sand, while others rival city blocks, and how shepherd moons keep edges sharp by stealing loose ice. By the end, you will feel yourself glide in slow orbits, breathing in rhythm with the steady spin of this beautiful gas giant. Good evening, everyone, and welcome to another gently fact-filled expedition through the cosmos. I promise peaceful sleep will arrive before our voyage concludes. Please share in the comments what part of our blue planet you call home. and what time your clock displays right now. It is always delightful to know which latitude and longitude cradle your pillow this evening. Remember to subscribe for daily celestial journeys, but please tap that button only after you sail into deep, restful sleep. Otherwise it will not count in the mission log. Let each muscle relax as though gravity has lowered its volume. Our journey through the universe tonight begins on a viewing deck aboard an orbiting research vessel named Whisper. Whisper hovers just outside Saturn's main ring plane, bathing in pale golden light reflected from cloud tops below. Saturn's atmosphere is mostly hydrogen and helium, giving the planet its soft pastel bands and lightning storms that flash silently in vacuum. Scientists have watched these storms linger for months, longer than any thundercloud on Earth. Below us, the rings appear solid, yet they are incredibly thin, seldom thicker than a city office block. This planet's rings likely formed less than 100 million years ago, making them younger than many dinosaurs once roaming Earth. Their brightness suggests constant recycling, with collisions chipping fresh ice from older fragments. We angled the vessel toward the outer ring, guided by a small shepherd moon named Pan. Pan orbits inside a gap called the Encke Gap, clearing debris with gentle gravity. Its shape resembles a flying saucer, because ring particles collected along its equator over time. Ice grains in this region are nearly pure water, sparkling like powdered diamonds. Light from Saturn's distant sun scatters through them, casting faint rainbows on Whisper's hull. We passed near a propeller feature, created when an unseen moonlet disturbs nearby ice. These propellers are signs of hidden bodies, too small to be full moons, yet large enough to carve spiral wakes. Next, we glide above the wider Cassini division, a dark band between the A and B rings. This gap exists because the moon Mimas tugs particles away every time they complete 2 orbits for its one. Such gravitational rhythms are called orbital resonances, and they sculpt the ring system like invisible hands. Beneath us, the dense B ring glows brightest, reflecting sunlight in broad ripples. The B ring holds most ring mass, though its precise thickness remains a mystery because radar signals scatter unpredictably. Some models suggest hidden wake structures, long ridges of ice packed like traffic on a quiet highway. We slow the vessel and descend into the ring plane, where particles drift at walking speed relative to us. Impact sounds are muffled through hull plating, soft taps like distant rain on a greenhouse roof. Each fragment follows Kepler's laws, orbiting faster when closer to Saturn and slower when farther, maintaining graceful order. A lone boulder tumbles gently, its surface carved by countless micro-impacts that left tiny glittering craters. These micro-impacts release dusty jets that give the rings a faint, ghostly atmosphere called the charged particles from Saturn's magnetic field collide with this dust, creating ultraviolet glows invisible to human eyes. Whisper's sensors translate these glows into gentle tones. We can hear a quiet chime rising and falling. We record the melody, labeling it Ring Song 1. Farther out lies the F ring, narrow and braided like silver rope. To shepherd moons, Prometheus and Pandora, tug at this ring, pulling strands that twist into beautiful knots. Prometheus steals material on each pass, then releases it, creating bright streamers that fade over hours. This dance repeats every 15 hours, a cosmic loom weaving and unweaving ice threads. Some F-ring particles form temporary clumps, dubbed moonlets, which appear and vanish within days. These moonlets collide gently, spraying ice flakes that keep the ring vivid and fresh. We angle upward, leaving the ring plane. Below, Saturn's cloud tops whirl in bands, moved by jet streams reaching 1,000 miles per hour. Near the North Pole sits a geometric wonder, a hexagon-shaped storm larger than Earth, rotating like a vast atmospheric gear. No other planet shows such a stable six-sided vortex. The pattern may form where westward and eastward winds meet, creating standing waves frozen into shape. We pause to admire this silent hexagon bathed in winter twilight. Saturn's year spans almost 30 Earth years, so each polar season lasts more than 7 Earth years. Long seasons allow storms to evolve slowly, giving them time to grow into immense, mesmerizing structures. You breathed deeply, imagining cool hydrogen wind brushing against your visor. Let your heart beat slow to match the planet's calm rotation. Feel the stillness settle, like snow on a quiet evening street. We adjust our course toward Titan, the largest moon of Saturn and the second largest moon in this entire solar system. Titan has a thick, golden-orange atmosphere made mostly of nitrogen, similar to Earth, but with a hazy twist of methane. Krakenmare is so wide it could hold all of the 5 Great Lakes combined. Its air pressure is slightly higher than Earth's, and radar scans map its dark, glassy surface, which means if you stood there in a protective suit, you would not need a pressurized helmet. It is the only moon known to have lakes and rivers, though. They are filled not with water, but with liquid methane and ethane. Like the faintest exhale across a candle flame, we see how wind direction changes their curves over time. Raindrops fall from thick orange clouds, forming streams that carve winding canyons through icy highlands. One of Titan's largest lakes, stretching for hundreds of miles, Whisper floats slowly above this alien sea. Waves rise less than 1 foot high, barely rippling the stillness due to Titan's low gravity and thick air. Wind there is gentle, feeding Saturn's fainty ring with fresh material. In this world, passing close to Enceladus sprays plumes of icy water from its south pole. Another moon with surprises. Methane behaves like water, flowing in rivers, and the grains feel like plastic powder if touched, evaporating into clouds and falling again in a cycle all its own. The dunes of Titan ripple across its equator. These dunes are made not of sand, but of dark hydrocarbon grains formed from particles falling from the upper atmosphere. The color is charcoal gray. Flying over these endless ridges, Whisper's instruments detect faint electromagnetic pulses rising from below, possibly from a salty ocean hidden beneath the crust. This ocean could be as deep as 200 miles, locked beneath layers of ice and rock. If life were to exist here, it would have to be very different from life on Earth, thriving in cold, dark, and chemical-rich conditions. We leave Titan slowly. Though much smaller, These plumes come from underground reservoirs. NASA's Cassini spacecraft once flew directly through a plume, finding water vapor, organic molecules, and salt. This discovery made Enceladus a top candidate for hidden life in our solar system. The ice particles fall back onto the Moon's surface, making it the most reflective object we know. Sunlight bounces off Enceladus so strongly that it appears almost white in the sky. The ice crust hides a global ocean, warmed by tidal forces from Saturn's pull. As the Moon stretches and flexes, internal heat builds, keeping the subsurface liquid from freezing. We drift above the tiger stripe cracks, where the geysers rise, listening to distant hisses of escaping vapor. The sound is soft and steady, like wind through a grove of pine trees. Back toward Saturn we return, where smaller moons orbit within the rings themselves. Atlas, Daphnis, and Pandora all help keep the ring structure neat, though their orbits can wobble slightly over time. Daphnis creates wave patterns on the edges of the Keeler Gap, forming graceful ripples that mimic the wakes of boats on a pond. These ripples measure only a few kilometers high, but their shapes remain visible for days. One moon, Janus, shares its orbit with another moon, Epimetheus, every 4 years. They swap places in a cosmic dance without ever colliding. This phenomena is called co-orbital motion, and it is rare in nature. They act like careful partners on a skating rink, moving in harmony despite their shared path. We sail past Hyperion, an oddly shaped moon that tumbles chaotically instead of spinning steadily. Its surface looks like a sponge, filled with deep craters and low gravity that lets dust escape. Because Hyperion has such an irregular shape, its rotation is unpredictable and never repeats the same way twice. It is one of the few objects in this solar system that exhibits true chaotic motion. Nearby, Iapetus shows a mystery of its own. Its surface is half bright as snow. Scientists believe dust from another moon may have coated one hemisphere, while the other remained icy. A tall ridge runs along Iapetus's equator, making it look like a walnut from some angles. This ridge may be the remains of a long-elapsed ring, or the result of early rapid spin that pushed material toward the center line. Whispered drifts over this towering wall, silhouetted against a slowly turning planet below. The silence is deep, the kind that hums gently behind your thoughts. Take a moment to breathe slowly, imagining yourself curled up in the corner of the ship's viewing lounge. Let your eyes grow heavy as Saturn's slow rings spin like ancient clocks. Outside the window, the sunlight begins to dim as we enter the planet's shadow. You feel the peace of slow orbits, patient moons, and a gas giant whispering across the void. Our journey through the rings continues as we turn toward Saturn's northern hemisphere. The winds on this planet are powerful, faster than any storm found on Earth. In some regions, they reach speeds of over 1,000 miles per hour. The air is mostly hydrogen and helium, like the sun, but much cooler and denser. There are no solid surfaces here, only thick clouds and deeper layers of gas. As we float downward, the clouds become denser, shifting from soft cream colors to deeper golden browns. Saturn's upper clouds are made of ammonia crystals, which swirl into sweeping patterns shaped by the planet's rotation. Below those, deeper clouds form from hydrogen sulfide and water ice. These clouds mix slowly, forming soft bands that stretch across the entire planet. Some of Saturn's storms are centuries old, locked into powerful jet streams that guide their paths. The most famous of all is the hexagon, at the planet's north pole. This hexagon is a six-sided weather pattern, larger than Earth, and stable for decades. Scientists believe it is caused by jet streams moving at different speeds around the pole. Its edges are sharp, not rounded like a typical hurricane. In the center of the hexagon is a massive polar vortex with an eye nearly 2,000 miles wide. This storm spins like a spiral galaxy, rising many miles above the surrounding cloud layers. During the Saturnian summer, sunlight illuminates the vortex, revealing layers of swirling haze and storm cells. Winds circle around it at over 300 miles per hour. The pattern is so stable that it returns season after season, never drifting from its place. We drift just above the northern cloud tops, watching the golden clouds swirl in endless slow motion. The air outside is thick with ammonia haze, softening the sunlight into pale pastel colors. Faint flashes of lightning flicker far below, where deep thunderstorms rumble inside the gas layers. These lightning bolts are more powerful than anything on Earth, sometimes thousands of times stronger. They light up the planet's clouds with brief, silent sparks. Deep in these clouds, scientists believe water-based storms may exist, much like those on Earth. These storms could create hailstones, made not of ice, but of diamonds. High pressure deep within Saturn may compress carbon into diamond crystals that fall like rain. These diamond rains would eventually melt in the heat below, never reaching the core. Beneath the clouds lies Saturn's metallic hydrogen layer. Under immense pressure, hydrogen becomes so dense that it starts to act like a metal. This strange form of matter can carry electric currents, generating Saturn's magnetic field. Saturn's magnetic field is strong, but not as strong as the one around Jupiter. It creates glowing auroras at both poles, where charged particles from the sun collide with gases in the upper atmosphere. Unlike Earth's auroras, Saturn's glow in ultraviolet light, invisible to the human eye. Our ship's sensors translate them into color, casting a soft lavender shimmer across the poles. These auroras pulse and shimmer, changing shape with each solar gust. Back inside Whisper, soft lights flicker along the observation dome, mimicking the auroras outside. The ship moves gently now, following the curve of the equator. Below us, the ring shadows stretch across the golden clouds like dark threads. We pass over a long, thin band, called the equatorial jet stream. This stream flows faster than the others, whipping around the planet's waist. Just above the rings, tiny particles spin in sync, barely larger than grains of sand. Some are icy, others rocky, each moving with perfect grace. Saturn's gravity holds them in orbit, shaping their paths through delicate pressure and pull. A small moonlet slips through the rings, leaving a spiral wake behind it. These trails can last for days, slowly twisting with the planet's rotation. Even the tiniest moons leave gentle brushstrokes in this frozen painting of motion. We are nearing the end of this passage through Saturn's rings and clouds, but not the end of its story. You are safe and weightless now, adrift in the beauty of this giant's gentle embrace. Our course now turns outward, toward the edge of Saturn's glorious ring system. The rings may seem solid from a distance, like a giant disk around the planet, but they are made of countless individual particles, each orbiting at its own graceful speed. Some particles are the size of sugar crystals, others are as large as school buses, tumbling end over end through the vacuum. The rings stretch out more than 280,000 kilometers from Saturn's surface. That is nearly 3/4 of the distance from Earth to the Moon. Yet the rings are incredibly thin, only about 10 meters tall in most places. That is thinner than a single story of a house compared to the entire width of North America. Imagine a sheet of tissue paper stretched over a football field. That is the kind of scale we are talking about. The rings are divided into 7 main sections, labeled alphabetically in the order they were discovered. The brightest and most massive is the B ring. It is dense, wide, and nearly opaque in places. The A ring lies just beyond it, separated by a thin gap called the Cassini division. This division is caused by the gravity of Saturn's moon Mimas. Mimas creates a resonance with ring particles that clears out this quiet path. Mimas is sometimes called the Death Star moon because of its giant crater. The crater is named Herschel and spans nearly 1/3 the moon's entire width. Farther out, the F ring dances with complexity. It is braided, twisted, and ever-changing. Tiny moonlets, called shepherd moons, orbit near the F ring. They pull on the ring's edges with every pass, tugging them into narrow streamers. They stretch and pull the ring into waves and knots. These shepherd moons are named Pandora and Prometheus. As they pass, no two orbits look the same. Even small differences in mass or path create stunning effects. Ring particles can clump together into temporary but Saturn's gravity pulls them apart again before they grow too large. This process repeats over and over, like cosmic breathing. The ring system is not permanent. It is slowly fading over time, shedding particles into space. Some fall toward Saturn as dusty rain. This dusty rain is made of charged ice grains that spiral along magnetic field lines. Scientists believe the rings may only last another 100 million years. That might sound long to us, but it is just a moment in the life of a planet. Saturn may have formed without rings, gained them later, and could lose them again. Some believe a moon was torn apart by Saturn's gravity to create the rings. Others think the material is left over from the early solar system. No one knows for certain, but watching them shimmer and swirl, one might think they have always been there. The outermost E-ring is faint and wide. It is made mostly of tiny ice particles from the moon. Enceladus is covered in bright ice and has geysers that shoot water into space. These geysers erupt from fractures near the South Pole. The ice and vapor feed the E-ring, making it the only ring in our solar system created by an active moon. Our ship slows as we reach the edge of this delicate loop. We are ready now to visit the moons of Saturn, each one holding mysteries of its own. Our first destination is the icy world of It is one of the brightest objects in this solar system, because its surface reflects nearly all sunlight. This reflectivity is due to a thick coating of freshwater ice. Enceladus is small, only about 500 kilometers across. That is about the width of the state of Arizona, but it holds a secret ocean beneath its frozen shell. Warm water escapes from cracks in the South Pole region. These cracks are nicknamed tiger stripes due to their blue coloration and long gashing form. The geysers blast a mixture of water vapor, ice particles, and organic molecules into space. Some of the particles become part of Saturn's E-ring, others fall back to the Moon's surface, creating a snowy landscape. The geysers are powered by tidal heating. As Enceladus orbits, Saturn gravity flexes its interior. This movement produces enough warmth to keep its hidden ocean in a liquid state. The presence of liquid water, heat, and organic chemicals makes Enceladus a top candidate for potential life. Some scientists think microbial life could exist in its underwater seas. Next, we glide past Titan, Saturn's largest moon. Titan is bigger than the planet Mercury. It is the only moon in this solar system with a thick atmosphere. This atmosphere is made mostly of nitrogen, like Earth's, but it also contains methane, which forms clouds and rain. Rivers and lakes on Titan are filled with liquid methane and ethane. Instead of water, the largest lake is called Krakenmeer. It is larger than the Great Lakes combined. The shorelines of these alien seas are sculpted by waves and rainfall. Titan's surface is cold enough to freeze water solid like rock. Beneath its crust lies another possible ocean of liquid water. Some think this ocean may also contain ammonia, which lowers the freezing point. If life exists on Titan, it might be very different from anything on Earth. We drift now toward Iapetus, a moon with a stark contrast. One half is dark as coal, while the other is bright as snow. This dramatic coloring puzzled astronomers for centuries. The dark side is covered in a thin layer of dust from outer moons. This dust absorbs sunlight, warming the surface. The warm ice sublimates and travels to the cold side, making it even brighter. This thermal feedback enhances the contrast over time. Iapetus also has an equatorial ridge, a giant mountain range circling its waist. This ridge is so tall that it makes Iapetus resemble a walnut. Its origin remains a mystery. It could be the remains of a collapsed ring or a frozen equator bulge. Now we visit Hyperion, a lumpy moon that spins and it tumbles chaotically through space. Its surface is spongy, filled with deep craters. Hyperion is extremely porous, like a cosmic pumice stone. It has a density so low that it would float in water. Some of its craters are dark inside, likely filled with frozen hydrocarbons. Its low gravity means impacts leave unusually shaped holes instead of flattening them. We now prepare to head back toward the rings, brushing past the shepherd moons once more. As we return to the rings, we pass by Pandora. Pandora is one of the small moons that helps shape the outer edge of Saturn's narrow F-ring. Along with its companion Prometheus, it creates gravitational tugging that keeps the ring in check. These moons are called shepherd moons. Prometheus The inner shepherd steals particles from the F-ring. Pandora, the outer shepherd, chases them away again. Their gravitational dance stirs ripples and streamers in the ring's structure. This dynamic interaction makes the F-ring one of the most chaotic and ever. The F-ring sometimes shows sudden bright clumps and strands that twist and tangle. Scientists believe these may result from collisions with small, hidden moons. The F-ring is narrow, only a few hundred kilometers wide, but incredibly long. If unwrapped, it would stretch nearly 600,000 kilometers in length. That is 1.5 times the distance from Earth to the Moon. We drift slowly now toward the inner B-ring. The B-ring is the brightest and most massive of all Saturn's rings. It spans over 25,000 kilometers in width. Its particles range from tiny grains to house-sized chunks. Despite its massive appearance, the B-ring is still incredibly thin. It is only about 10 meters thick. The brightness of this ring comes from its high reflectivity. This ring reflects more sunlight than freshly fallen snow. We now float through a quiet space between the B and A rings. This region is known as the Cassini division. It was first observed by astronomer Giovanni Cassini in 1675. He saw the division through a primitive telescope and could only imagine its cause. Today we know it is caused by a gravitational resonance with one of Saturn's moons. That moon is Mimas, the Death Star-like moon with a massive crater. Every time a ring particle orbits Saturn twice, Mimas completes one orbit. This repeated tug creates a gap, pushing particles away over time. Mimas itself has a large crater called Herschel. Herschel spans 1/3 the diameter of the entire moon. If Earth had a crater that size, it would stretch from New York to California. We pass now beneath the shimmering ring. It lies farther from the planet than the B ring. The A ring contains a curious feature known as the Encke gap. Within this gap orbits a small moon named Pan. Pan looks like a flying saucer. It has a pronounced equatorial ridge created by gathering ring particles over time. Pan's gravity clears a path through the ring, sculpting the gap. Its orbit causes waves and wakes to ripple through nearby ring material. Another small moon inside a ring gap. We drift past Pan and turn toward Daphnis. Daphnis orbits within the narrower Keeler gap. Its motion creates vertical waves along the ring's edges. These waves can rise up to 1.5 kilometers tall. They resemble ripples on a pond, but in the icy vacuum of space. As we drift beyond Daphnis, we begin to notice another mysterious feature within the A-ring. These are the propeller-shaped disturbances scattered through the ring. They are caused by moonlets, too small, too clear, full gaps. Instead, their gravity disturbs the surrounding ring material, forming patterns that resemble airplane propellers. Each of these propeller features can stretch for several kilometers. The moonlets themselves are often just a few hundred meters wide. They are like hidden pebbles creating ripples in a frozen pond. Some of these propellers have even been tracked over time, slowly migrating within the ring. They have names inspired by famous aviators and explorers. One of the most prominent is nicknamed Blériot, named after the first man to fly across the English Channel. From here, we begin our descent toward the D-ring. The D-ring is the innermost and faintest of Saturn's main rings. It lies closest to the planet and is barely visible. Its particles are very small and sparse. Over time, it appears to be slowly spiraling inward. Some of its material may even fall into Saturn's atmosphere. This ring is constantly reshaped by Saturn's magnetic field. In 2011, a sudden bright spiral formed in the D-ring. Scientists believe it was created by a meteor impact. This spiral pattern gradually wound tighter over time. We now approach the C-ring, nestled between the D and B rings. It is sometimes called the crepe ring due to its dim, gauzy appearance. The C-ring contains many mysterious ringlets and waves. These patterns are shaped by oscillations inside Saturn itself. These are known as density waves. They are like seismic tremors traveling through the rings. By studying them, scientists can infer details about Saturn's interior structure. It is a form of cosmic seismology. The C-ring also has zones where particles are mysteriously missing. These are known as plateaus, where density drops for unknown reasons. Some scientists believe electrostatic charging plays a role. The particles in the C-ring may cling together like tiny magnets. We now float above the equator of Saturn, gazing down upon the full expanse of its rings. From this height, they resemble the grooves of an ancient vinyl record, each ring etched with the story of collisions and creation. Saturn's ring system spans over 280,000 kilometers from end to end. That is nearly 3/4 of the distance from Earth to the Moon. Yet the entire system is only about 10 meters thick. If you stood in the rings, you would hardly see them at all. Despite their size, the total mass of the rings is relatively small. All of Saturn's rings together weigh less than one of its moons. Their mass is roughly equivalent to that of the Moon mass. This has led to debates about how long the rings might last. Some scientists believe they are slowly eroding. Particles fall into Saturn or drift away. In time, Saturn may become a ringless planet. But for now, they remain a breathtaking spectacle. Beyond the main rings lies a vast region known as the E-ring. This ring is incredibly wide, stretching from the orbit of Mimas to that of Titan. It is also the most diffuse of Saturn's major rings. The particles here are tiny, mostly despite its faintness. It is primarily fed by one of Saturn's most intriguing moons. Enceladus is a small, icy world with a hidden ocean beneath its crust. From its southern pole, Enceladus ejects plumes of water, vapor, and ice. These geysers erupt from long fractures called tiger stripes. As the plumes escape into space, they feed the E-ring. This makes the E-ring unique among Saturn's rings. It is the only one actively replenished by a moon. The particles from Enceladus are fresh and clean. This gives the E-ring a brilliant blue color when viewed in certain light. It is one of the few rings in the solar system with such a hue. The plumes of Enceladus were first observed by the spacecraft Cassini. Cassini flew through the jets multiple times, sampling their contents. It found salty water, simple organic molecules, and even traces of hydrogen. These ingredients suggest Enceladus could harbor life. If so, the E-ring might be made partly from the breath of alien oceans. You might feel like you are swimming through a veil of snow. floating slowly through this ring. But unlike snow, the grains are shaped by the forces of electromagnetism, solar radiation, and Saturn's magnetic field bends the paths of these grains. This makes the E-ring appear differently depending on where you are. In sunlight, it shimmers faintly. It nearly vanishes. In shadow, it is a ring of whispers and absence. Farther out still, we reach the G-ring. This ring is even more mysterious than the E-ring. It lies between the orbits of Mimas and Insomnia. For many years, scientists could not determine what kept it alive. Eventually, they discovered a tiny moonlet named Aegion. Aegion orbits within the G-ring and acts as a source of fresh particles. Collisions with micrometeoroids kick up dust from its surface. This dust feeds the ring, much like Enceladus feeds the E-ring. Aegion is only a few kilometers wide, almost invisible on its own. Yet it sustains an entire segment of Saturn's architecture. The G-ring is shaped into an arc by Saturn's magnetic and gravitational forces. This gives it an asymmetric appearance, like a drawn-out sigh of ice. Even farther still lies the vast Phoebe ring. The Phoebe ring is unlike any other ring in the solar system. It is the largest and most distant of Saturn's rings. It begins about 6 million miles from the planet. It stretches for more than 10 million miles beyond that. If visible to the naked eye, it would span the width of 2 full moons in the sky. Yet it remained undiscovered until 2009. The reason is that it is made of dark, nearly invisible material. Most of its particles are made from carbon-rich dust. This dust barely reflects sunlight. The Phoebe ring is tilted relative to Saturn's main rings. It orbits in the opposite direction of most of Saturn's moons. This makes it a retrograde ring, an unusual feature in planetary systems. It is named after the moon Phoebe, which orbits within the ring. Phoebe is an irregular, captured moon thought to come from the Kuiper belt. The Kuiper belt is the same region where Pluto resides. This gives Phoebe and its ring a mysterious, ancient quality. The particles in the Phoebe ring were likely knocked loose by micrometeoroid impacts. These particles drift inward slowly over millions of years. Eventually, they interact with other moons, including Iapetus. Iapetus is another of Saturn's most fascinating moons. It has one side that is bright as snow. Its other side is dark as soot. The cause of this contrast is partly due to the Phoebe ring. Dust from the ring collects on one side of Ia. As the moon orbits Saturn, it sweeps up dark material. This darkening warms the surface, melting nearby ice. The melted ice then migrates away, leaving even more dark material behind. This process is called thermal segregation. It is a slow transformation sculpted by shadow and sunlight. So even though the Phoebe ring is faint, it leaves a lasting fingerprint. It alters the surface of entire moons. It shapes worlds in silence. Its particles are ancient, some possibly older than Saturn itself. To float through this ring is to move through time. There are no dense bands of ice here, only faint wisps of dust drifting like ashes in twilight. The silence would be absolute. The stars would look sharper out here. Without the reflection from icy rings, space would seem darker. This is where Saturn's gravity begins to loosen its hold. Beyond the Phoebe ring, interplanetary space stretches outward. Tiny particles from the ring drift farther still. Eventually, they are captured by the solar wind. Some are carried toward the sun. Others escape the solar system entirely. They become dust in the galaxy, tiny remnants of Saturn's most distant halo, and so the story of Saturn's rings ends not with a wall of ice, but with a whisper of dark dust fading into the stars. We now turn our attention to Saturn's mighty This is a vast bubble carved into the solar wind by the planet's magnetic field. It is second in size only to Jupiter's magnetosphere. Charged particles stream outward from the Sun. Saturn's field catches and bends them like a gentle net. Some of these particles spiral down magnetic lines into the upper atmosphere. They collide with hydrogen, releasing ultraviolet light. Although invisible to human eyes, instruments paint these lights in lavender. The auroras form rings around both poles. They pulse in rhythm with solar storms, millions of kilometers away. During strong outbursts, the auroras brighten and climb higher. Their shapes ripple and twist like silent curtains. This is Saturn's way of singing with the sun. Spacecraft have recorded faint radio waves linked to these lights. The sounds resemble distant whistles and chirps. Listening to them feels like tuning a fragile music box. These radio emissions vary with the planet's rotation. They allow scientists to measure Saturn's true day length. Saturn's cloud bands hide the rotation of deeper layers. The magnetic pulse provides a more reliable clock. It ticks every 10 hours and 33 minutes. A day on Saturn ends almost before lunch on Earth. Yet the planet's atmosphere flows more slowly in places. Cloud belts near the equator move at slightly different speeds. This creates shear zones where storms grow. Cassini observed one great storm encircling the planet in 2010. It began as a small white dot. Within weeks, it wrapped around the globe. Lightning inside that storm flashed 10 times more brightly than any on Earth. Each bolt illuminated clouds hundreds of kilometers wide. Storm clouds rose high enough to poke into the stratosphere. This stirred chemicals such as ammonia and they created hazes that lingered for many years. Some of those hazes drifted toward the rings. They stuck to icy particles. Over time, ring particles darken as they sweep up this falling rain. Scientists call this process ring rain. It is one reason the rings will slowly lose brightness. Ring rain also carries water vapor into Saturn's upper atmosphere. This vapor can alter cloud chemistry. Everything in the Saturn system, from rings to moons, is linked. Pull one thread and another trembles. We steer whisper toward a narrow window between ring particles. The ship's shields deflect small grains, like raindrops on glass. Each tap sounds like a gentle drum roll in the hull. Outside, sunlight dims as we dip within the shadowed side of the rings. Icy particles glow faintly, lit by the planet's reflected light. It feels as though we are sailing through frozen stardust. We pause engines and drift, letting Saturn's gravity carry us forward. You breathe deeply, matching your heartbeat to the quiet orbit around you. As we drift silently beneath the rings, particles cast shadows on one another. These miniature eclipses create speckled light patterns across our ship's hull. Each particle, no larger than a snowball, tumbles slowly in Saturn's grip. Some rotate like lazy tops, while others remain still, frozen in eternal pause. These icy grains reflect about 60% of the sunlight that strikes them. That makes Saturn's rings among the most reflective surfaces in the solar system. Some of the brightest areas shine like freshly fallen snow. Their gleam is so intense they can be seen with small backyard telescopes. The quiet beauty surrounding us is deceptive. The rings may appear solid from a distance, but they are mostly empty space. If you compressed all the material in the main rings, it would form a moon no larger than 100 kilometers wide. Their thinness is also surprising. Most of the rings are only about 10 meters thick. That is less than the height of a diving platform at an Olympic pool. Despite their vast spread spanning over 280,000 kilometers, they are razor-thin compared to their width. The rings are labeled from inner to outer as D, C, B, A, F, G, and E. These names were assigned in order of discovery, not their physical placement. The B ring is the thickest and brightest of them all. It blocks much of the light from Saturn during occultations. Between the A and B rings lies the Cassini division. This dark gap is not truly empty, but contains fewer, darker particles. It is kept clear by the gravitational influence of the moon. My mass, sometimes called the Death Star moon, has a giant crater called Herschel. This crater is over 100 kilometers wide, almost a third the moon's diameter. If my mass were any larger, gravity would have pulled it into a more spherical shape. Its orbit resonates with the particles in the Cassini division. As my mass moves, it nudges these particles into new paths, clearing space like a cosmic broom. Farther out lies the F ring, a narrow, twisted ribbon guarded by shepherd moons. These moons, Prometheus and Pandora, tug the ring into braids and knots. Sometimes particles break away, only to be herded back by gravitational nudges. The F ring is dynamic. Its shape changes with every orbit. It may appear fragile, but it has persisted for millions of years. The E ring is even more delicate. This ring is composed mostly of microscopic ice grains. It is replenished continuously by the moon. Enceladus spews water vapor from icy geysers near its south pole. These plumes reach hundreds of kilometers into space. As the vapor freezes, it adds to the E-ring's shimmering veil. This ring stretches farther than any other, spanning nearly 1 million kilometers. It is so faint that it can only be seen when lit from behind. Despite its size, the total mass of the E-ring is barely measurable. Its presence, however, reveals the hidden breadth of Enceladus orbits within the densest part of the E-ring. Its surface is coated in bright ice, making it one of the most reflective objects in the solar system. Over 90% of sunlight that hits Enceladus bounces off. Its high reflectivity is partly due to its constantly renewed surface. Each geyser eruption repaints the moon in frosty white. These eruptions are powered by tidal flexing Saturns. Gravity kneads the moon like dough, This kneading generates internal heat, keeping pockets of liquid water beneath the crust. That subsurface ocean could be more hospitable to life than anywhere else beyond Earth. Scientists believe that heat, water, and organic molecules have all been detected there. If life does exist, it might dwell near thermal vents, just as it does on the floor of Earth's oceans. Back near the rings, the tiny shepherd moons keep order. Prometheus dips into the F-ring, stealing material and creating streamers of particles. Pandora's gravity pulls gently at the outer edge, keeping the ring confined. The resulting gravitational tug-of-war forms bends, gaps, and spirals. These patterns evolve hour by hour. If you could watch the F-ring for a full day, it would appear to breathe. Just beyond, the G-ring is a ghostly band of dust particles. It was long overlooked due to its dim nature. Scientists discovered it using light scattering during spacecraft. The G-ring is fed by a small, mysterious moon named Egion. This moon is only about half a kilometer wide. Its collisions with nearby debris help sustain the faint ring. Farther still, the D-ring brushes close to Saturn's atmosphere. It is the thinnest and faintest of the main rings. Its particles spiral inward, eventually falling into the planet's upper clouds. When that happens, auroras may shimmer near Saturn's poles. These auroras are created by interactions between ring matter and Saturn's magnetic field. Saturn's magnetic field is symmetrical and like Earth's and remains a puzzle for planetary scientists. Its field may be shaped by deep liquid layers beneath the cloud tops. These layers, rich in metallic hydrogen, generate electrical currents. Such currents give rise to the magnetic field, which rotates almost in perfect alignment with Saturn's spin. This symmetry may be why the length of Saturn's day is so hard to measure. It was once estimated using radio waves, but those signals fluctuate. Now, scientists track surface storms to refine the timing. Saturn's day lasts roughly 10.5 Earth hours. Its seasons, however, span over 7 Earth years. This is due to its wide, 27-degree axial tilt. As Saturn orbits the Sun, its rings shift like a giant celestial clock. Sometimes we see them sometimes they bloom fully open, like petals on a cosmic flower. During equinox, sunlight strikes the rings, edge on, casting long shadows onto the planet. These moments are rare and reveal details usually hidden in glare. Saturn's rings may seem eternal, but they are slowly disappearing. Gravity drags their particles into the planet at a rate of 10,000 kilograms per second. Over time, this process will erase them. In 100 million years, Saturn may become a planet without a halo. But for now, the rings are here, and they are singing. Yes, Saturn's rings generate a soft radio hum as particles collide and bounce. The Cassini spacecraft recorded these ethereal sounds during its orbit. Scientists converted them into audio, revealing chirps and whooshes like an alien lullaby. These songs are not audible in space, but with instruments, they become a kind of music. Some say it is the solar system's most delicate symphony. You can imagine drifting in your ship beside them, eyes closed, listening. Every ring seems to whisper its own quiet tone. The A ring chimes, broad and full. The B ring crackles with hidden voices. The F ring sings softly, like wind against silk. Saturn is not just a planet, it is a performer in a celestial ballet. Each moon, each ring, each shifting shadow, lakes, and even rainbutt, made of methane, not water, moves with intention. Back on Titan, storms of methane swirl above smooth plains. Titan has rivers. These hydrocarbon lakes are so cold, they do not evaporate like water does on Earth. When Titan rains, you would see the orange sky and its pale reflection below. It rains slow. Drop by drop, the methane collects and carves canyons. Some lakes are larger than the Great Lakes of North America. Kraken Mare is over 1,000 kilometers wide. The largest, if you could float across it, you might feel small, but not alone. The surface of Titan may one day support robotic sailboats. NASA has plans to explore its lakes in coming decades. Beneath Titan's crust, a salty ocean could cradle something living. Because his telescope was too primitive to resolve the rings, it would not breathe oxygen, but it might still thrive in alien ways. Back on Earth, we look up at Saturn with backyard telescopes. Even small scopes can show its yellow globe and the edge of its rings. Some observers say Saturn is the most beautiful object in the night sky. Galileo was the first to see it, but he did not know what he was looking at. He thought Saturn had ears. Later, astronomers revealed their true form. Christian Huygens correctly identified them in 1655. Over centuries, new details emerged: the gaps, the moons, the shadows. Now, even amateur astronomers can track Saturn's changing view. From Earth, the rings seem to tip up and down across the years. It is because of Saturn's tilt and our own moving orbit. Sometimes we see the rings wide open, like outstretched arms. Sometimes they disappear entirely, turning edge on and vanishing in a single night. These changes are reminders that space is not frozen. It moves slowly, but never stops. Saturn may seem timeless, but it is just one chapter in the solar system's unfolding story. Its rings are not permanent, but they are beautiful while they last. You were lucky to visit them tonight. You counted shadows in the B ring and listened to Enceladus breathe. You drifted between icy particles and traced the tides of Titan. You watched lightning storms light up Saturn's golden clouds. And now, with the journey nearly complete, it is time to close your eyes and rest. Let us float a moment longer, here, just beyond the rings. The ship is quiet now. There is nothing left to chart. No more facts to memorize. No more moons to visit tonight. Only silence and a slow, distant turning of shadows. The stars are blinking softly above your vessel. Saturn's rings glide past your window like whispered memories. They are drifting ice. Yes, but tonight they are something more. They are a lullaby you can feel in your chest, like a rhythm older than the world, older than any name. Perhaps the universe does not speak in words. Perhaps it speaks in orbit and echo. And tonight, it has told you everything it needed to. It showed you how rings are made of broken moons and quiet collisions. It showed you that even gas giants can spin with grace. It reminded you that even frozen storms, millions of miles away, still dance with light. You followed a beam of sunlight across thousands of kilometers of frozen dust. You counted craters on my mass like they were freckles on a sleeping child. You listened to the vapor plumes on Enceladus breathe like waves. You drifted beneath Titan's orange skies and imagined alien clouds. You saw Saturn tip and twirl, wearing its rings like a shimmering scarf. And all the while, you listened. You listened to gravity hum. You listened to light bend. You listened to silence. Fill the space between stars. You learned that even silence has texture. That space, even at its emptiest, is never truly empty. There is always motion, always warmth, always light, even if faint. And even now, as Saturn spins behind you and the stars stretch ahead, you are not leaving this moment behind. You are simply closing your eyes and carrying it inward, like a comet cradling starlight. Let your breath become slow and even. Let your body feel as though it too is drifting through the rings. Let your thoughts rise like methane bubbles on Titan's lake, weightless, silent, timeless. You are safe here. You are home, even so far from Earth. The ship will keep floating, the stars will keep turning, and the rings of Saturn will keep singing quietly in your dreams. Thank you for traveling with Insomnia in space. If your eyes are still open, you can gently close them now. But if you are still awake, let me ask, would you like to continue this series from another moon, another world, or let Saturn rest in memory for now? Let me know and comment down below. Campfire sounds and shooting stars will remain to guide you the rest of the way down.